We're going to go ahead and start off talking a little bit about density curves, but that's really going to lead us into the main point of this lesson, which is z-scores and being able to calculate percents of data that falls below or above or between certain data values. Now, a density curve is a mathematical model. It's always on or above the x-axis or horizontal axis. The total area is always 1. So remember that very important total area, always 1. Well, of course, then the area between two values is always going to range somewhere between 0 up to 1, but most of the time somewhere in between there. So normal distribution is really the type of density curves that we're going to focus on. Now, if you really want to geek out a little bit, here's the equation to give you these bell-shaped curves down here. Now, E is your natural number. E, pi is the pi that you deal with circles. Sigma right here is the standard deviation. Mu right here is the mean of the data. Really kind of some fun stuff if you get into the math of it. But most of you probably won't. But normal distribution is always this bell-shaped curve right here. Now, depending upon how big your standard deviation is, and standard deviation is just how spread out your data is, depends upon whether the curve is tall and narrow like this or shorter and wider like this. But in all cases, it's symmetrical. As in, you have a line here that cuts your graph in half. You have a line here that cuts your graph in half. That line that cuts your graph in half so that each side's mirror image of it is always your mu, which is your mean. Now, when we're dealing with normal distribution, if you are 1 standard deviation on each side of your mean would be 0. You could be 1 standard deviation above to 1 standard deviation below. That's always 68% of your data. Or if you go to 2 standard deviations in each side of your mean, so go from 0 all the way up to 2, or 0 all the way down to 2 within 2 standard deviations on each side of your mean, that's always 95%. And then similarly, if you go to 3 standard deviations on each side, that's 99.7% of your data. That allows you to be able to calculate, kind of say, well, what percent of my data is below this number, what percent's between these numbers, and so on, and so on, and so on. So, once again, if it's normal distribution, you can say, well, 1 standard deviation on each side of your mean is 68%. 2 standard deviations on each side of your mean is 95%, and so on. So, how do you figure out how many standard deviations you are on each side of your mean? Well, that's what z-scores are about. Here's our formula for z-scores. We have x, which is our particular data value that they're asking us about. Then we have our mean of our data that we're dealing with over our standard deviation of the data. Now, if your data value is above the mean, your z-score is going to be a positive number because you're above. But if your z-score for your data is negative, or your data value is below the mean, your z-score is going to be negative. So it's very important that you remember that a z-score is just how many standard deviations you are above or below, if it's negative, the mean. And from there, you can go ahead and figure things out. So suppose we have a situation like this here. We have SAT scores. The mean is 500. The standard deviation is 100. And if a student scores a 700, what would their z-score be? Meaning, how many standard deviations are they above the mean? Well, we know we're above because 700 is larger than our 500. Well, we got to go ahead and plug in our information here. Our standard deviation, 100, that goes on the bottom. Boo! There we go! Then we got to go ahead and take our mean and plug it in for that mu. Boop! There we go! And then we're wondering about our 700. That's our data value going in for x. Boo! There we go! All we have to do now is figure this out. Simple subtraction on top, we get 200. Then we got to do our division by 100, gives us 2. So that means our score of 700 is 2 standard deviations above the mean. So that means we have 2 standard deviations above would put us about right here. Now, what does that mean? Well, that means somebody getting a score of 700 would score better than all this area here. So if we could figure out that percent of that area, remember the whole thing is 1, we could go ahead and figure out this student scoring better than what percent of the people. This over here would be telling us the percent of the people that scored better than 700. So we're able to compare things.